Hello everyone, I am Basavaraj Magdum from Sri Venkateswara College of Engineering, Bangalore. My technical seminar presentation on real-time implementation of face recognition and emotion recognition using convolutional neural network under the guidance of Professor Ashwini A.M. My contents are introduction, history of technology, proposed methodology and block diagram, results, application, conclusion, and reference. Coming to the introduction, emotions are mental reaction shown by the body to a specific thing or a action through a behavioral and physiological changes in the human body. The movement of facial features creates facial expression. All persons' expression are different. According to Meher Bien, spoken words transmit 7% of communication, voice conveys 38% of message, and facial emotion conveys 55% of message. Emotion recognition has its application in healthcare, entertainment, learning, marketing, human monitoring, and security. The face recognition and emotion recognition using CNN system work by the analyzing facial images to identify the person's identifier and emotional states. For face recognition, the CNN takes an input images and applies a series of conventional layer to extract the features such as the shape of the face, location of the facial features, and texture of the skin. Those features are then compared with the feature of known face in database to determine the person's identifier. For emotion recognition, the CNN takes an input images and analyze the facial recognition to determine the person's emotion state. The CNN first identifies the key facial landmark such as the position of the eyebrows, mouth shape, and eye openness. These features are then used to classify and emotion states such as happy, sad, angry, or neutral. Coming to the history of technology, the conventional neural network architecture is the type of the neural network that is widely used for image and video recognition tasks. CNNs are designed to automatically learn and extract the features from the images by applying a series of convolutional and pooling a layer. The development of CNNs can be traced back at 1980s when the scientist colleagues at AT&T Bell Laboratories developed the first neural network capable of recognizing the hardware digits. This network, known as the Net5, was designed for character recognition in check processing systems. In the following years, researchers continued to refine the architecture of CNNs. One important breakthrough come in 2012 when the team of the scientists at the University of Toronto won the ImageNet large-scale visual recognition challenge using deep CNN called AlexNet. Today, CNNs continue to be major area of research in field of the deep learning with a new architecture and techniques being developed to improve their performance on a wide range of tasks. Coming to the proposed methodology, the methodology for face recognition and emotion recognition using CNN typically some of the steps. First one is data collecting. The first step was data collecting. To collect the data of the images for the training and testing the CNN for the face recognition. Dataset may include the images of individual from the different angles, lightning condition, and facial expression. For emotion recognition, the dataset may include the images of the individuals with different emotional expression. And next step was data pre-processing. The data set is pre-processed to normalize the images and remove any noise or artifacts. This step may include image resizing, cropping, and filtering. The next step is training the CNN. The next step is training the CNN using the pre-processed data. The CNN is typically trained using a many images and their corresponding labels. The CNN learns to recognize a pattern in the images that are the associated with a specific individual or emotion. And next step was fine-tuning the CNN. After the training the CNN, it is often fine-tuned using additional data sets to improve its accuracy and performance. Fine-tuning may involve adjusting the hyperparameters of the CNN. And the last step was testing and evolution. The final step is to test the CNN using separate dataset that was not used for training and fine-tuning. The accuracy and performance of CNN are evaluated using metrics such as precision, recall, and F1 score. The methodology for face recognition, emotion recognition using CNN can be further enhanced by the incorporating additional techniques such as the data augmentation, ensemble, some methods, attention mechanism. These techniques can be improved the robustness and generalizability of the CNN, making it more effective for real world application. And block diagram, the CNN works by the analyzing facial images to identify the person identity and emotional state. For face recognition, the CNN takes the input to images and applies series of the conventional layer to extract the features such as the shape of the face, location of the facial features, example nose, eyes, mouth, and texture of the skin. These features may then compared with the features of known face in a dataset to determine the person identification. For emotion recognition, CNN takes the input images and analyzes the facial expression to determine the person's emotional state. The CNN first identifies the key facial landmarks such as the position of the eyebrows, mouth shape, and eye openness. These features are then used to classify the emotional states such as the happy, sad, angry, or neutral. The system works by the first collecting and pre-processing the data set of facial images. The pre-processed images are then used to train the CNN using supervised learning techniques. The training CNN in this fine-tune and testing using the additional data set to improve its accuracy and performance. In operation, the system captures and images of a person's face using camera and other devices. The images are pre-processed to standardize it for analyzing and then passed through the CNN for the face and emotion recognition. The system output the person's identify and emotional state, which can be used for a wide range of applications such as security, marketing, and healthcare. The test result obtained face recognition and emotion recognition for two popular computer vision tasks that have received a lot of attention in recent years. Conventional neural network have been shown to be highly effective for these tasks, achieving state-of-the-art performance on various benchmark data sets. Face recognition using a CNN involves the training a neural network to learn the mapping between the facial images and corresponding identify the networks is typically trained using a large data set of labeled facial images and learns to extract the relevant features from these messages that are the indicative of the person's identify. The performance of the face recognition system is the typically evaluated using the metrics such as accuracy, precision, and recall. So this is the output we will get like emotions such as the fear, sad, happy, emotional, like this we will get the result. And the applications are security purpose, entertainment purpose, healthcare, and education purpose and marketing. In security purpose, for example, they can be used at airports, trains, station, and other public places to identify the individual who poses a security threats. And coming to the entertainment, for example, they can be used in video games to create more impression experience on movies, theaters to adjust the volume and lighting based on the emotion of the viewers. And coming to the healthcare, for example, can be used to monitoring the patients with depression and anxiety and provides the earlier intervention when he needed. It also used in the uh, education. For example, adjust the pace and the difficulty of lessons based on the student's emotional response. And last one is marketing, where we can applies the marketing in CNN. They can be used to track the consumer emotion, respond to advertise and adjust the marketing strategy accordingly. So last conclusion. Face, emo- face emotional recognition is the latest technology that has gained a lot of significance in the recent year. It is essential, helpful in the field of the medicine and computer vision, with its enhancement and development over the next few years. In this project, I have develop a CNN model for facial emotional recognition using a CNN and multi-classes classification along with the hyperparameter tuning. The optimal data ratio for the training and testing was found to be accuracy, respectively, for the CNN model to provide the best accuracy for emotion recognition. Hence, the impact of the CNN tuning on the model's accuracy is quite significant and helpful as it paved ways for the many future works which can be later to improve the scope of the research area. This is the human emotion recognition using CNN. So these are the some of the reference paper I took for to present a presentation on the face mask face emotional detection using a CNN. So thank you for your time being here.